Hi there, we're applying structural engineering, looking at this idea of uniformly distributed load on a beam. So we have point loads, 50 kilonewton, 13 kilonewton, and then we have this idea that we've got a uniformly distributed load. Could be anything, generally floors, things like that. It's a wide area of the same weight, basically. So the same weight is distributed over, more than a meter, basically. So the idea is 10 kilonewtons per meter is the weight of this material, this item. So what would we do? Well, to do our calculations, we want to convert it into what we call a point load so that everything's really clear. We've got our loads and then we've got our reactions. So how would we do this? Well, if you look pictorially, the idea of having 10 kilonewtons per meter, if you've got a 4 meter length, it means it's 10 kilonewtons for every meter length. So that would be, you just add them up and it's 40. If you're thinking formula wise, this is the formula. If you imagine kilonewtons per meter, how do you get it to a point load of just kilonewtons? Well, the way to cancel out that meter at the bottom would be to times it by meters, right? So as long as you know the number of meters and you know how many kilonewtons per meter, you just times them together. So that's the formula there. And you end up with 40 kilonewtons. So the next thing to consider is, where is that point load going to go? And it's right here, bottom right hand corner. So we now have a 4 meter length. We have converted distributed loads into a point load, and you just put it right in the middle. So just center of gravity idea. That's where you would put it. So that's now got a nice beam calculation ready to roll. So we've got all our point loads. I know you can see university distributed loads here, but if you think about different types of beams, what we would need to calculate is the reactions. So the idea is you've got these loads pushing the beam down. So what's going to hold it up? Well, actually, you need to have an equal reactive force coming in the opposite direction. Otherwise, you would just be sinking, wouldn't you? The beam would just sink and keep going downwards if the columns holding it up were not strong enough. Yeah. So that's the concept here. So it's reactions we're trying to calculate. Once we know what the loads are, we need to know what the columns are now going to withstand. So reactions are basically the columns, yeah, the material that's holding these beams up. So if you've got a cantilever beam, you've only got one because you've got the wall that's holding it, or the column, depending if the cantilever beam's hanging off a column or a wall. When you've got a simply supported beam, this is what our standard, where you've got two walls or two columns and you've got this beam sort of spreading in between. And then the third one is your continuous beam, where you've got lots of columns holding it up. So they're your three types.